Hi guys, this is Mr. BHANU MOORTHY. Welcome to BMS Academy of Objective Physics. Now, today in this video class, we are going to discuss, I am going to project electric potential and electric field strength, the relation between them. Some beautiful concepts are there in this lesson. So listen carefully. Now, generally, a positive charge, a point charge, a positive charge establishes electric field in its surroundings. You know that point very well. Now, this positive point charge behaves like a torchlight. For example, I am comparing torchlight, zero bulb will be there. When torchlight is on, light passes in the forward direction, away from the torchlight. Similarly, electric charge, that point charge behaves like a torchlight. Okay, so electric lines of force move perpendicular or move forward direction away from the positive charge. The intensity of electric field is away from the positive charge. Whereas if you place a negative charge there, the intensity direction is towards the negative charge. So intensity direction is away from the positive charge and towards the negative charge. This is the first point in this chapter. Beautiful concept. So intensity direction, intensity of electric field means electric lines of force direction is away from the positive charge and towards the negative charge. So this is the first point. Now let's go to next one. So this is called uniform electric field. In uniform electric field, all electric lines are straight and parallel, you know that. Okay, so in this uniform electric field, so beautiful concept is there. If positively charged particle is just dropped, a positively charged particle is just dropped in this uniform electric field, what happens? So it gets accelerated in the direction of electric field. So because when a positive charge is dropped, it runs in this direction, in the direction of positive electric field. So it gets accelerated. Its velocity increases gradually in the direction of electric field. Whereas when it in opposite direction of the electric field, it gets retarded. If you push that positive charged particle in this direction, it retards and finally comes to rest position. But whereas in the direction of electric field, it moves, it speeds up, it gets accelerated. Okay, so we can calculate acceleration of the charged particle as EQ by m. Okay, my dear students, this is very important concept in entrance examinations, IIT, NEET and CBSE entrance examinations. Now we are going to discuss about velocity. Velocity after some time means after 2 seconds, after 3 seconds, its velocity we want to calculate. So v equals to u plus at. So u is 0 because it is just dropped there. Then velocity equals to at. A means this one into t. So velocity after 3 seconds. Now, what is the third parameter? Momentum of the particle. Particle gets accelerated, no? So momentum of the particle is mv. So mass into this velocity. So mass gets cancelled, you will get eqt. So this is the momentum of the particle gaining in the direction of electric field. Now finally, kinetic energy gained by the particle because it gets accelerated, no? Its kinetic energy gradually increases. What is the gain in the kinetic energy? Means p square by 2m. You can substitute p value here, then use e square, q square, t square by 2m. So these are the parameters of the charged particles whenever it is dropped in the electric field. Okay, so or any parameter, from any parameter they may ask in entrance examination, IIT Mains, IIT Advanced and NEET examination, and for the CBSE students also they may ask this question. So this represents the motion of a charged particle in uniform electric field. My dear students, I think you caught this point. Next, some examples we can give. Proton and alpha particle both are projected in uniform magnetic electric field. If proton and electron both are projected at the same time, starting from rest position, so both are projected in uniform electric field, then what is the ratio of their velocities, what is the ratio of their accelerations, what is the ratio of their momenta, what is the ratio of their kinetic energies? All these parameters, ratios we can calculate. So this is a very important and crucial point for entrance examination. Okay, so now whenever electron is dropped, very interesting now, positively charged particle dropped, it gets accelerated in the direction of field, and negatively charged particle is given electron, for example, it is dropped. then it gets accelerated against the direction of field and gets retarded in the direction of field. The beautiful concept it is. Okay, so already they asked in an entrance examination this point. Which one accelerates in which direction? Which one decelerates in which direction? So they asked it already in entrance examination. Okay, next one, third concept let us enter into. This is the point charge. Electric field is away from the positive charge. This is positive. Electric field is away from the positive charge. So we are considering A, B, C, D, 4 points. So at these points, intensity gradually reduces, So focus reduces gradually as distance increases. So with respect to distance, the intensity gradually reduces, whereas potential also gradually reduces. So potential decreases away from the positive charge. So I given the relation among these points. So VA greater than VB greater than VC greater than VD. So potential gradually reduces in the direction of field. Direction of field here, the potential gradually reduces with the distance. So intensity versus potential relation is negative potential gradient. Means what is the representation of minus there? So minus represents that the potential gradually reduces from the point charge, the potential gradually decreases in the direction of electric field. So decrease represented by negative sign. My dear students, remember this point, the significance of negative sign there. Okay, so decrease in the potential with the distance in the direction of field. Okay, so now E varies with respect to R square and potential varies with respect to inversely to R. Okay, E is inversely to R square, V is inversely to R. That is a relation between these two. So once you enter into the academy, once you join in this academy, we can discuss more and more concepts. We can discuss such type of maximum number of concepts, such type of maximum number of problems, numericals, we can solve in the exam, in the classroom. Okay, so that you can increase, you can develop your awareness in the subject. Okay, so it is a most prestigious institution now, BHANU Moorthy's Academy of Objective Physics. If you join in this institution, if you enroll your name by dialing to this number, then you can get more and more awareness in the subject. So the choice is yours now. I don't want to tell. Okay, now this is the fourth concept. Now I am going to represent some isolines. What are meant by equipotential surfaces? Equipotential surfaces means, suppose this is one surface. Potential at all points is same. That is called as equipotential. The surface on which potential is same at all points. That is equipotential. So like that, 4 equipotential surfaces I given to here. This is a numerical problem asked in entrance examination already. Okay, so 4 isolines are given there. Isolines of potential means equipotentials are given there. So the potential on this line at all points is 10 volts. The potential on this line at all points on this line is 20. The potential at all points on this line is 30. The potential at all points on this line is 40. So all these 4 lines are represented as equipotential surfaces, isolines of potential surfaces. Okay, now these 4 isolines of potential are given like this. Now at distance is 0, 1, 2, 3 meters. They are represented in meters. Okay, on x-axis distance is given, on y-axis potential is given. Then 4 isolines of potentials are given to you, equipotential surfaces. Then the question is what? What is the magnitude of intensity? What is the direction of intensity at any point? The beautiful concept here. So if it is isoline, then potential intensity direction. If it is isoline of potential, intensity direction is perpendicular. If the isoline is like this, intensity direction is perpendicular. If the isoline is like this, intensity direction is perpendicular. So what is the observation? So intensity direction is always perpendicular to the equipotential surface. Now my dear students, so this is the equipotential surface. For this equipotential surface, I want the intensity. I want to draw the intensity. So intensity direction is perpendicular. So I want to draw perpendicular like this. This is perpendicular intensity direction. So the direction of intensity is asking now. The direction of intensity for any line of isoline is perpendicular to the potential surface. For any surface you take, it is perpendicular. Okay, intensity direction is perpendicular to isoline. So this is 90 degrees, this is 90 degrees, and this is 45 degrees, because already given as it is 135 degrees between the equipotential surface and x-axis. 135 is given. Then between the intensity and x-axis 45 degrees is there, and this is the dr. So this is isoline, this is intensity direction, and this is dr. dr means 3 minus 1. dr means distance, displacement between these two, any two isoline surfaces. So 3 minus 2, that is dr. But condition is there, dr and E should be on the same line. That is a condition, you should not forget that. So this is intensity, this is dr. dr should be resolved into this component. So dr cos 45. So if it is E, it is dr, this is dr cos 45. So finally you have to select this formula. Then I am writing here E equals to minus dV by dr cos theta, dr cos 45. So according to this relation you can calculate magnitude of the intensity. Okay, so that is minus dV means 30 minus 20 or 20 minus 10. Between any two successive isolines, the potential difference is 10, divided by distance between any two successive lines, that is 1. Okay, 1 meter. 3 minus 2, 2 minus 1, that is 1. Cos 45 is 1 by root 2. So finally what? Minus 10 root 2. So intensity direction it is. Okay, intensity direction is 10 root 2 with the positive x-axis or negative x-axis, means with x-axis. So 45 degrees with x-axis represents direction, 45 degrees intensity direction, 45 degrees with respect to x-axis, and the magnitude is 10 root 2, my dear students. So this is also very important concept. It's a concept of potential on isoline. Okay, isolines and equipotential surfaces versus intensity relations we discussed in this video class. If you are interested to join this institution, so many problems are there, so many concepts are there, magnificent concepts are there, nearly 40-50 concepts are there. According to me, each and every topic is conceptual in this academy. So unless you know the concepts, in this chapter or any subject, any topic, then it's not possible to solve the problems, numericals. So conceptually you should get awareness now. So for that purpose you should join in this prestigious institution. There is no other alternate. So please enroll your number and reserve your seat number in this academy, because there is a quarreling between the students to reserve their seats now. So competitive field it is. Okay, so I am particularly objective type of conceptual type of tutorial master I am. So that's why so many concepts we can discuss in the academy. Okay, numerical problems we can solve, as we mentioned in the curricular programs in the previous video class. You go through that previous video class, then get the schedule, then reserve your seat by dialing this number. It's my number. Then we can discuss each and every one. Okay, no? So whenever you get the free time, you ring to that number and clarify your doubts. Okay, so if you are interested to join in this institution, please like, share and press the bell button. Okay, so you can get the notifications for that. So my dear students, in the next video class I am going to present some capacitors chapter. Capacitors are also beautiful concepts, you know. So it's not possible to discuss each and every concept in the video classes. It's a feel that it's a demo class from me. So if you are interested, you can join this institution. So then bye. Till then, bye. See you in the next video class regarding capacitors. Right.